Okay, so we are actually on question 2b of the review, and we are going to find the functional notation for each of these values. And remember, when dealing with a piecewise function, you have to pay attention to which one of these inequalities over here is satisfied. So our x value here is a 3. If we look here, 3 is not less than 0. But 3 is between 0 and 4. So we're going to plug it into this piece, which will give us 3 squared plus 1. And that is 9 plus 1, or 10. All right, now let's do f of 6. If we look, 6 is not less than 0. It's not between 0 and 4. But 6 is greater than 4. And this is the piece we'll plug into. There's no x there, so there's nothing to plug into. We're always going to get -1 for that piece. All right, now let's do f of 0. Now, let's notice that 0 is not less than 0. However, since there's an equal sign here, 0 is equal to 0, so that will work. We need to plug it into the middle piece. So this will give 0 squared plus 1, plus 1, which will give us 1. All right, now let's do our last one, f of -3. If we look up here, -3 is less than 0, so it satisfies this piece. We're going to plug it into this piece. There's no x, nothing to plug into, so we just get 2. All right, so let's also get our domain and range, and I'll go back to the graph we did in the previous, here is our graph from our previous video. And let's get the domain first. Let's think of a trash compactor crushing the graph onto the x-axis. All of this is going to go down onto the x-axis. So is this open circle, but this closed circle is going to fill it in. And then all of this is going to come straight down. This is going to come straight down to the 4 as a closed circle. So when this comes up, it'll actually get filled in. And then each of these. So let's notice that really, as we trash compact it, the domain is all real numbers. So our domain is -infinity to +infinity. The range, however, is going to be a little strange. So the top part is easier to think about. If we think about crushing this toward the y-axis, all of this is going to get covered in between. And this right here is all going to come onto that point right there. So from here up, and up to this point right here, it's going to get covered. But we need to know what that point right there is. Well, let's notice that that is our parabolic shape. So really, if we put the x equals 4 in here, we can find out what that y value is. It's 16 plus 1. It's 17. Okay, so that y value way up there, this is the 0.417. That means our range is going to stop at that y value because that will be the last thing that gets pushed over here. So it's going to go from 1 to 17. All right, so both 1 and 17, both of those y values are on the graph. All right, now you might say, well, what about the other part? But we're going to get it. We're going to use a little union symbol to mean also. This, when we crush it, everything is going to go to the y value of -1. Remember that nothing crinkles when we crush it, so all of these will go to just the single y value. So instead of an interval notation, since it's a single value, we want set brackets. And we're just going to put that -1 there to indicate that there's one single value also at -1. So that one's a little strange. Okay, so time-wise, I'm doing good. Okay, so let's go ahead and do this transformation of this function in number 3. And I think I can just copy and paste it. And I'll copy and paste it down here. All right, so we're going to graph this. Now what we have to note first is there's a square here, meaning that it is a transformation of our parabola. So let's just draw our parabola x squared first. So it's a transformation of x squared. Now let's remember what's out to the side is a vertical shift. So this takes it up 1. And then what's inside of our square, inside of that operation, is the horizontal shift. Always the opposites though. So this is left 3. And this is an easy enough one that we can do both of them at one time. I know that doesn't look like left. Okay, so let's go left 3 and up 1. Normally this starts at 0, 0, and I sort of missed there, but let's think of our 0, 0 point going left 3 and up 1. I'm just going to put it right here, and then we just redraw our parabola. And there it is. All right. So let's do the same thing with the second one. Now, I think there was some stuff to fill in there. So it has the shape of the function y equals x squared or f of x equals x squared, whichever way you want to say it, but it shifted 3 units left and 1 unit up. All right, now let's look at this one. And let's do the same thing to it. I might need to open a new sheet. Okay. All right, so let's recognize this has a square root. So my library function that I start with is the square root function, which looks kind of like a rising hill. All right, so out to the side is our vertical shift. That's going to take it down 3. Inside of the square root is our horizontal shift. Remember, that's always the opposite. So this is left 2. And then outside the front of this thing, that negative flips it across the x-axis. We call that a reflection. All right, so let's go ahead and move it left 2. So it starts at 0, 0. So if we move it left 2, it's going to start right here instead. All right, then let's flip it across the axis, and I'll just use a different color to show the flip. So if I flip it across the axis, it's going to end up looking like this blue graph. And then let's move that blue graph down 3. So I'll make a new graph here. It's now going to start 3 places down. So it's going to start right there. Let me change the color for the new graph. And if I make that, remember we're changing the blue graph, not the orange. So it's still got this shape. And there's our final graph. And so if we go back to our sheet, this has the shape of the function y equals the square root of x, but is shifted 2 units left, is reflected across the x-axis, and is shifted 3 units down. All right, so let's look at 5, which is still the same idea, and I'm doing good time-wise, so I think we'll get through 5 all right. See if I can copy it, if it will let me. Okay, so let's recognize everything in this one. First of all, notice it's squared again, which means it's our parabola. So we've got our parabola again. And I keep missing 0, 0, but we know it's supposed to hit there. All right, this is our vertical shift. down 3. Inside of the square is our horizontal shift. Remember, in the opposite direction, so this is right 5. And then out front is our flip across the x-axis, or our reflection across x. Okay, so let's go right 5. It's supposed to be at 0, 0. So when I go right 5, well, that's not very straight, but I've now got a parabola. Ugh. Let's erase that. Try it again. I've now got a parabola. That's looking a little prettier. It starts right there. Okay, now let's flip it across the x-axis. I'll just change the color and do it on the same graph. So if I flip it down, it's going to look like an upside down version of the same thing, like so. And now let's move it down 3. So it was starting right here at 5, 0. Now it's going to move down 3 places. And so when I redraw this graph, I want it to start down here. So let me actually make the grid like this. All right, so we're over 5 places. And we're down 3 now. And so my new graph is going to start right there. Still upside down though. And it will look like that. All right. Let me see what the next one is. I've got 3 minutes left. I might need to just do another video. I think I'd better just to make sure we don't run out of time.